And it is my very great pleasure to welcome you back to the live stream and to direct your rapturous virtual applause to Mr. Joshua Locke, who will talk to us on the joys of securing your supply chain with SLSA.
Okay, hello everyone. Thanks for taking the time this evening. My name is Joshua Locke. I am employed by Verizon, who are a very large telecoms provider in North America. And one of the advantages of my role there is that I get to spend time working on open source software and riding trains to speak to people like you about things like this. So SLSA is a project that I happen to work on in that capacity, and hopefully I'll provide an adequate introduction this evening. So the agenda is pretty simple. I'm going to introduce you to my dancing metal goose friend. I'll talk a bit about what is SLSA, how you can use it, if you're a platform team, how you can implement SLSA, and some of the things we're trying to do in the SLSA project in the future. So what is it? Well, it's a clever acronym, of course. It stands for Supply Chain Levels for Software Artifacts. It's also very DevOpsy, I think. It's an open source security framework. It's designed to help prevent tampering during the software production process. And in trying to set up best practices, it's focused on what we call tracks, which are specific elements of the software supply chain. It has incremental levels so that it's easy to kind of onboard and improve security over time instead of having to be a binary all or nothing affair. It focuses on being automatically verifiable, and in order to do that, it roots a lot of the trust in kind of hardened platforms. So that's that automation, centralization, and consistent platforms. Then the notion of doing everything kind of as code so that it's easier to do machine verification, what I think make it a good fit for DevOps-minded folks. So you might think, well, best practices, who defines what's best? And the answer to that question is that this is rooted in a lot of research and development. And I think about 10 years ago now, Google started talking about a set of projects they were doing, which were part of a larger effort to increase the sophistication of their systems to help defend against insider threats. One of the core tenets of this kind of system is that you can't affect a change in a Google system without multi-party approval. So that might be code review, that might be requiring a second administrator to sign off on you getting admin privileges to a build system, those kind of things. And more recently, there were a spate of high-profile software supply chain attacks, kind of culminating in 2021, I think it was, when SolarWinds was compromised. And as a consequence of this and the increased focus on software supply chain security, Google generalized their binary authorization for board principles and opened them up as a collaborative project for multiple people to help make these tenets kind of applicable for a broader set of systems. Google's systems are notoriously opinionated, and the SLSA project, one of the aims is to make those practices more applicable to more disparate systems. And it's a really nice kind of industry collaboration. There's rough consensus among diverse industry collaborators. The logo soup on the screen doesn't describe all of them, just the ones who were kind of proactive enough to have their logos submitted to the repository. There's a lot more of contributors, and there's also a lot of implicit input. So I like to come to places like this and talk to smart people and learn, and often these ideas will be brought back into the project by myself and others who collaborate. And in order to be able to direct a disparate group of people with very different experiences and opinions, we have a set of guiding principles for the SLSA project. And this helps us ensure that we are focused and consistent in how we develop the guidelines and requirements that we specify. So the guiding principles are quite simple. We strive to trust platforms and verify artifacts, which means there's a corollary that we must minimize the number of platforms that we trust. The more platforms there are, the more hardening and the more attack vectors there are. We trust code over individuals. We prefer attestations over inferences. I've underlined attestations here because we have a nice open standard that we collaborate with the in-toto project on called in-toto attestation. So that's a kind of keyword that I thought was worth highlighting. And then we have simple levels with clear outcomes. So I mentioned the incremental nature of SLSA. If you can, if you look at the SLSA specification, should be very clear what you get by implementing the next level. So what your current security properties are and what you will achieve by implementing the next level. So parts of this slide didn't load. Try reloading. Thank you. Oh, well, show it anyway. Oh, that's useful, isn't it? The part that didn't load is the important part. I can show you the title. Tracks and levels. Okay. So SLSA is designed to be a series of tracks which describe aspects of the supply chain you would like to harden. And as I was just talking about, you can incrementally incrementally implement these levels. And right now we have one track which is kind of marked as version 1 and is, shipped and ready to implement and is being implemented by multiple people, and that is the build track. And so the build track is focused on preventing tampering against unauthorized changes in the build process. I'm going to go to get into that a bit more over the next few slides. So when I say tampering, when the SLSA specification says tampering, this is, I think, a great visual for what we're trying to achieve. We'd like to know if someone has taken our software and done something that we didn't expect with it. And so you get, medical equipment and things that have this this tamper-evident tape that helps you see if someone else has been in the packaging before you have. And there are many examples of this happening in practice. I work primarily in open source, so that's the domain that I'm mostly going to talk about. And back in 2018, this project called Webmin, which is like an administration console for your servers. It's very old-fashioned concept now. Everyone's running on the cloud, not running servers in their home lab. But back when people were doing more of that, this was like a web UI to help facilitate administrating those systems. And that they discovered that over numerous releases, a backdoor had been introduced into the releases of their software. And if you went to their source code repository, everything looked great. And if you got a distribution package, everything looked great there because the Linux distributions tended to be packaging this from the source code itself. But if you downloaded from their website one of their release artifacts, then you got this little backdoor. And it turned out they had, the attacker had managed to get onto the build server and introduce a malicious version of the code that was getting packaged on that system, which was, I think, hosted in someone's home. More recently, I mentioned SolarWinds Corporation had a major compromise resulting in federal government departments and banks and everyone's data being exfiltrated. Very upsetting turn of events, ruined everyone's Christmas that works in kind of software supply chain and build systems and those kind of things. It was a really sophisticated sequence of compromises that enabled them to do this. But ultimately, there was no way to detect when code that wasn't the code that was retrieved was being built. And so some different classes were being compiled into the code and shipped to, authenticated by the signing process at the end of the build and then shipped to all of their customers. Another example, last one, CodeCov, around the same time actually, 2021, they had a script that you could integrate into your pipeline to upload coverage results to their service, and neither their container images, which they recommended you use, or their instructions about how to set up this script included using the checksum that they published on their website to verify that the script was as intended. And so when an attacker managed to modify the script, everyone was fetching it and running it and uploading more than they intended to different places. So I think we've indicated unauthorized modifications can take many forms. This is a common image that's used to indicate a software supply chain, a fairly typical software supply chain, and the different points at which compromise can happen. And the build track of the SLSA project is focused on this little area here. Attack C is building from modified source, which is like the webmin example. Attack E is compromising the build process itself, like in the SolarWinds example. And attack F is uploading a modified package to wherever you publish your packages to, somewhat like CodeCub. So now that we've presented the kind of the landscape, what about, well, how can we use SLSA to help defend against these things? And I'm really excited that nowadays when I give this talk, I've been giving talks about SLSA since I've been involved, which is, I don't know, 18 months, 2 years now. And early on when the standard first was published and we were developing it in public, people would ask me how to use it. And I'd say, well, you kind of got to do a lot of work. And that's not a very satisfying answer. But nowadays, there are multiple projects you can use which implement SLSA. So if you happen to be building packages for Linux distributions, you can use the Open Build service from SUSE, which will get you to SLSA build level 3. If you are authoring NPM packages, NPM actually has built-in support in the NPM tool itself for generating SLSA conformant provenance metadata. If you happen to tie that with a GitHub action, you can get to SLSA build level 2. These would be more meaningful if my slide had loaded correctly, so I apologize for that. I'll try and remember to load up the SLSA website and show you. In fact, maybe I should just do that now. Let's peek behind the curtain, see how the sausage is made. And this is the SLSA website. And what I had tried to include in my slide is this, this table here, which says if you have SLSA build level 0, which is you've not done any of these things, you're kind of in a bit of a no person's land. If you've implemented build level 1, you will have some provenance metadata that shows you how your package was built. And that helps prevent kind of mistakes in the software production process, which are less common in a very DevOps aware world, but still happen from time to time. I was reading about an example just earlier today, and I've forgotten what it was, but a automotive in-vehicle entertainment system manufacturer pushed the wrong software update because someone fat-fingered the release process. So a bunch of motor vehicles on the streets were suddenly running unanticipated software. It's 2023, everyone. This is very alarming. So yeah, SLSA build level 1 will help you defend against those kind of issues. If you get to SLSA build level 2, you start to sign the metadata that you have generated, and you're ensuring that you're running that on a build platform rather than on someone's kind of workstation or something. And that gives you some protection against tampering after the build. And build level 3 is our highest level right now. It involves some hardening of the build platform, making sure that the build processes are running in an isolated environment. And this helps prevent tampering during the build process, which is clearly very desirable. Okay, it's really hard to see. There we go. So, SLSA build level 2, absolutely nothing to sniff at. That's great. Well done, NPM. Happen to know the GitHub package security team are working on more improvements along those lines. So that's very exciting to see what else happens there. We also have an open source project primarily authored by folks at Google, which is called SLSA GitHub Generator, and that uses a combination of features of the GitHub Actions platform and an open source project called Sigstore to provide SLSA build level 3, which is fantastic. It supports NPM packaging, Go packaging, building containers, and I believe either exists today or is working process packaging things in Java. And then very recently, it was announced that the Homebrew project, which is a system level package manager and installer for macOS and Linux, is implementing SLSA so that you can have the confidence that when you brew install something from Homebrew, it was produced on the build systems they expect and using the recipes that they anticipate. So very exciting places that you can start integrating Salsa today. So I've talked a bunch about kind of motivations for Salsa and a high level about some of the theory. So I'm going to try and offend the demo gods by giving a demo right here, right now. And it's not a true demo. I'm just going to show some windows and hope that it's going to be more difficult than I anticipate because I am not mirroring my screen, but here we go. I love a challenge. Oh no, fallen at the first hurdle. I am a technology professional. Do not worry. Okay, what can we do here? We can do this. Oh. There we go. Nope, not that way. This is why you don't do live demos, because you look like an incompetent person in front of a live audience. Hooray! And one more. There we go. You can do it. Check you out. No, that's upsetting. All right, we're going to try and make this work. So I have here difficult to see question mark GitHub Actions workflow. And what I'm doing here is I'm using the Salsa GitHub generator project that I just mentioned with a configuration file to build a couple of Go binaries. I wanted to say packages and I stopped myself because that's not true. Okay, so we're building a couple of Go binaries. And gosh, how many times can I show you my window switcher? I hope someone's taking count. One more time. Have all the displays. Here we go. So if I run this workflow on GitHub, the workflow I showed you was fairly simple. And that's because it's using this reusable workflow from the Salsa GitHub generator, which spawns a bunch of jobs to do a bunch of things, including generating random numbers, detecting the environment, building a binary that builds the projects I've asked it to build, actually doing the build, and then generating provenance. And one of the advantages of the GitHub Actions platform is each of these different jobs runs in different virtual machines with fairly constrained mechanisms for passing data between them. So you can put files on GitHub storage, or you can send basically strings over a like small pipe. And so all of your build stats are happening on different VMs. Your ability to tamper with them is minimal because the build stats are all defined by a third-party reusable workflow, which is maintained by different people, has different ACLs. You can't. You'd have to compromise a whole different set of people than the repository you're working in to be able to tamper with that. And then when the build's done, you get a bunch of artifacts, including the binaries you tried to build and some JSON files. So if I jump over to this window, I can look at one of those JSON files and show you, again, perhaps unreadable. There we go, hopefully that's better. This is a very big JSON file, look at that. It's got a bunch of information in it. What can we show? So this is the authenticated metadata about a build. You can see that it claims to follow some Salsa metadata formats, tells you the artifact that it's describing, the digest of that artifact, and then it encodes a bunch of information about where this thing was built. And this builder ID kind of describes the set of peoples and systems that you have to trust the output of this build. It encodes a bunch of parameter environment variables from GitHub. Tells you what was done during the build, so what commands were run, what inputs to the build. So my fork of a repository at this digest, and the virtual environment that the build was run on. So you've got a bunch of information in here, and then with that information, you can verify the output of that build. So this is a tool called SLSA verifier. I'm running the verify artifact command, and I'm saying, here's my metadata, my signed metadata about the thing. I believe it should have been built here on this builder. It should have been built from this source repository, and this is what was built. This is what I want to verify. So I have some policy about the artifact that I expect to be able to verify. And if I run that policy verification, you can see that this verification has failed. And the reason why is because I said I think that binary should have been built from source in this organization or repository, but it's actually been built from source in this organization and repository. And that's okay, because this is the upstream location and this is my fork, and there we go. That is where it was actually built from. So if I run the verification command again with my fork, it passes, it verifies. Now that may not seem very useful, but it is. It gives us some building blocks. And so just to talk about the GitHub generator a bit, like I mentioned, it's using GitHub features and the Sigstore project to meet SLSA requirements. So the reusable workflows give us isolation, the workflow identity, which ties into Marcel's talk. That's an OIDC grant. The GitHub Actions worker generates an OIDC token, shares that with Sigstore, and then Sigstore is able to say, I'm issuing a short-lived certificate to this worker, and then that gives you a chain of proof that this ran on the GitHub section builder that you expect, triggered from all of the places you expect, and we get SLSA level 4 build. Show my window switcher again, because I've lost the other part of my presentation. This is going swimmingly. Thank you for your patience, everyone. I think I'm going to be able to figure this out at some point. Not. Marvelous. Never mind. There we go. So slides. Okay, so that is how you can use SLSA with GitHub. But SLSA is more than just that, and that's a very kind of manual process. There's a larger ecosystem to SLSA. Like implementing SLSA is effectively an architecture of an ecosystem where you're producing software and consuming software in some controlled way, and you are able to define this policy that I evaluated. So the components of a SLSA architecture are that you have a trusted platform that can generate provenance and isolate the builds, a way to define those expectations, that sort of policy, and then a place to verify that policy. So one of the reasons I wanted to come to this meetup and talk about SLSA is because you kind of implement it in the platforms, and at the platform level, a lot of folks, DevSecOps folks, are operating and building platforms. But you don't have to start from scratch. You can build on these trusted build tools. Tecton Chains and Google Cloud Build both have support for generating SLSA provenance in the build platform. So we have a trusted platform we can use. That just leaves the expectations of verifications as kind of problems to solve for the team building the platform and the ecosystem. Your expectations are the policy that I defined on the command line. So that's, there are multiple patterns you could follow to implement that. You could do a trust on first use model where you kind of detect changes in the way the packages are built and trigger some action based on those changes. So if you suddenly start building packages from a different repository than you expect, then you can detect that drift by monitoring the metadata and take some remediation action. You might do something like Go, where you define in your source repository implicitly what the policy is, or you could have the package producer define the expectations. That might work well in the open source ecosystem where there is less central authority. So yeah, there's a few options for that. We're kind of playing around with those, exploring them. Really curious to get some people's inputs on what would work in the systems they build. And then your verification has to happen somewhere as well. In the NPM scenario, what they're doing is kind of at registry submission time, they're verifying that the NPM package that you've submitted was built from the repository that it claims to have been, or that at registration time, you register your package and you say it's in this GitHub repository or wherever else you're hosting. So you can, the NPM registry can verify that the build happened from the anticipated upstream source on the expected builder and prevent new packages being uploaded if they weren't built as expected. You could also do that install time. For example, in your NPM install, you can retrieve the provenance metadata from the repository and verify it at that install time, or you could do that in a Kubernetes admission controller. There's a bunch of possibilities, but I think the key part here is that SLSA verifier approach is kind of part of the puzzle, but it's somewhat low level. Clearly, you don't want everyone who's installing new software to have to say, I think this should come from here and have been built there. You need a way to define and transmit those expectations without the user having to do a bunch of work by hand. And setting those expectations forms a very core component of verification. This is an often unanticipated aspect of the SLSA process, is that if you have a super hardened build server, it can still produce bad code or bad artifacts. If you're not verifying that it came from the expected builder, was produced from the expected repository and commit-ish, and was built using the expected recipe, then that could, the trusted builder can still build bad things. These are just remote code execution as a service. So you need to build in this this notion of expectations, this notion of policy into your ecosystem in order to be able to gain the end-to-end benefits of the SLSA project. And so it's this verification piece that really brings the whole architecture together. You need that trusted builder, verifying the signatures on the envelope, and then verifying that the metadata, the provenance metadata, matches the expectations that you've defined. So we've talked a bit about SLSA projects, how you can use it, how you can build it into your platforms and ecosystems. I also talked about how the SLSA project is only defining this build track right now. So I thought it'd be worth sharing just a little bit about the things we'd like to do in the SLSA project in future. So we are actively working on what we call the source track, which is bringing some of that hardening to your source to builder portion of your pipeline. That's looking at, maybe we can make recommendations about how to harden the SCM platform. We would like to recommend code review and bring in this binary authorization for Borg notion of multi-party approval for changes to enter your pipeline. We haven't settled on exactly what the size of that, shape of that will be yet, but it's something we're actively investigating. There's also some talk about hardware-attested build platforms as a track within the project. So everything we have so far focuses on making sure that the build operates as expected, but if you can compromise an operator of the platform, how do you have trust in the machines and systems that the build runs on? So that's what this track is focused on. We'd also like to expand the build track. We used to have a notion of build level 4, which was an increased level of hardening of the build, and we ended up removing that before we shipped to 1.0 because it was really hard to communicate. You know, if I refer back to the SLSA principles, it was really hard to have that clear, measurable improvement at that level. So some desirable aspects of the build track, but we couldn't articulate them in a general and concrete enough way to figure out how to implement them across different ecosystems. But we would like to bring those back. And as I made very clear, I think in the past 5 or 10 minutes, we'd like to better understand some of the architectures that we can use to deliver SLSA outside of the places it's being used today, how we can do expectation forming and communication, and how we can do the verification piece in an automated, frictionless way. And I'd also like to invite ideas. It's an open source project, as I mentioned. We do a lot of collaboration through GitHub and Slack. There are frequent meetings which are not entirely unfriendly to people in UK time zones. It's 5 till 6 on a Monday and 5 till 6 once a month on a Thursday. So if you're interested in some of the things here and you think you can help shape them, move them in meaningful ways, we would very much welcome some participation. And just to summarize, we talked a bit about what SLSA is, why you might want it, how you can use it on your own projects today, some of the hand-wavy thoughts about how to build it into your ecosystems, and then what we'd like to do next. Just wanted to make sure I had the URL to the website very large and prominent somewhere in the presentation, so there it is, salsa.dev, nice and easy to remember. Okay, thank you again for your attention. Thank you for bearing with me as I fail to operate computer, and happy to take any questions. Comments, remarks, sorry, yeah. That's an insightful question. You must have done your homework. So the question was, SLSA has been released as SLSA 1.0. The SLSA GitHub generator declares that it implements SLSA 0.2, which was the original kind of public release of SLSA in an RFC state. Will the SLSA GitHub generator implement SLSA 1.0? Yes, it will. One of the things the SLSA GitHub generator folks are doing is trying to re-architect the system so that you can, they did an initial implementation which supported Go, then later added NPM, and they realized they were writing a bunch of very similar code for systems that they didn't really control or weren't really experts in. So they re-architected the system so you could have this notion of bring your own builder, so you can bring your own definition of how your build should work and build them within the SLSA GitHub generator ecosystem. And that, I believe, does implement the SLSA 1.0 provenance format. It was much easier for me to do the demo with the Go builder that I was familiar with and had used before, so that's what I used. But yes, absolutely, they want to support the latest formats. Folks who work on that are well involved in the SLSA project and contributing to both the standard and the implementation. So yeah, great question, thank you. Sure. Yeah. Yes. Okay. So, talking about the bootstrapping problem and the trusting trust problem, how do we trust the verifier, for example, or the different tools involved in producing and verifying SLSA artifacts? I showed briefly, I'm not going to do the window switcher thing again. I showed briefly that one of the GitHub artifacts that was generated during the build process was it's a builder binary with a digest. So you can actually take the SLSA GitHub generator binary that is built to build your project, download that, and verify that that came from where it came from, and sort of back up the trust chain a bit. But ultimately, yes, you do have to trust the platform at a certain point. That's a conscious decision of the SLSA project that you choose a trusted platform, you root your trust in that, and then the things that are built on top of that, you do the automated verification of. And so consequences of that are that, one, we as a SLSA project are trying to encourage build platforms to be more transparent about how they think they meet the SLSA requirements. So we have like a survey, we say, fill this thing in, describe how you meet SLSA requirements, and that helps people choose to trust you because they understand how you're achieving those requirements. And then another kind of consequence is some people choose not to trust these opaque build platforms effectively. And if you want to go very deep into the bootstrappable and trust problems, there's some really excellent open source projects, bootstrappable builds and reproducible builds, which are focused on how much of the tool chain can you build from an auditable source. Exactly, yeah. So GNU Geeks uses the bootstrappable builds project, which has a C compiler implemented in Scheme. So you can audit Scheme code if you can read the paren-based languages. There's a manageable amount of Scheme code. If you can read that and trust that, that can bootstrap the rest of the kind of tool chain. And so you can root your trust in this small auditable amount of code. And then the builds are binary reproducible. So if you build them in 3 different places and compare them all and they're all the same, and audited this kind of scheme-based seed, then you can have a lot more confidence that the whole thing is doing as it claims to be doing. Of course, every level of assurance, you then start to look with more scrutiny on the level below. So if you trust your compiler, you start to look at the hardware and think, well, I remember hearing a couple of years ago chip implants. So I think everyone has to define a cutoff point somewhere. And I think for most people, trusting the platform, making trust decisions based on platform is a reasonable start. Gets you a lot further than things have been so far, but there's definitely much deeper you can go, and there's some really, really cool open source projects. Geeks and Nix are package managers and distributions that include a lot of these features, and the bootstrappable builds project is like effectively trying to build a compiler that you can seed from a small amount of auditable Scheme code. Yeah, there's a lot of really cool work and a lot of cool writing published about that work, which I encourage you to look into. Okay, great question, thanks. Any other questions, comments, remarks, heckles? Yeah, okay. Good question. Yes, you definitely did do your homework. So the question was, this also specification includes this notion of verification summary attestation, VSA. How's that intended to be used? And ultimately, the intention of that is many people are interested in using SLSA to produce, to secure their pipelines, but then they don't want to leak all of that metadata about their pipelines to every consumer of the system. And so, or indeed, there are cases where I scrolled through the provenance attestation that was generated by the GitHub generator. That was a really simple piece of code that I was building, and the provenance was still a fairly decent amount of JSON. And if you're building very complex systems, that's a lot of JSON to analyze and ship around and things. So the verification summary whether it's for expediency and scalability reasons or for compartmentalizing trust. That was harder to say than I expected. Reasons you can have someone you trust summarize the contents of the attestation, the bits you actually care about, and then publish this much more condensed attestation summary. So yeah, one of the ways people imagine it working is, you know, your software producer is shipping products. They don't want to reveal the details of their pipeline, but they pay a security company to pen test their sell to build pipeline and then provide an attestation, verification summary attestation that says, like, we have evaluated that these details of the system are true. Or just having the company itself say, we're building SLSA 3, SLSA build level 3. You're going to have to take our word for it, but here's a verification summary attestation that says we're doing that. And yeah, there are definitely people that are using it for that scalability reason. They want to be able to share trust assertions on their internal systems without having to share the full fat JSON file for every package they build. A great question. Go ahead. Let me try and rephrase the question to make sure I'm understanding it for the audience. Do we only generate the problem? I think the question is, do we generate the provenance solely based on the build, or can we add additional attestations to that? Yeah, we have certainly talked about adding additional attestations and types of attestations, and the in-toto attestation format that I mentioned is generic enough. And people are working on, so SLSA provenance is like the way the in-toto attestation format works is you have this envelope of signed metadata. The attestation describes a vague structure, and then you have predicates that describe detailed metadata about different aspects of software supply chain security. And the SLSA provenance specifically describes the build, but there are other formats that describe whether you've done code review or whether you've run kind of a malware scanner or SCA analysis over your code and things. So there's people exploring how you can generate different kinds of attestations to improve the kind of auditability of the entire software supply chain. And then there's a great project called Guac, which is like a knowledge graph for all of these attestations and different other kinds of metadata that you can pull about your packages, so that you can make really rich and detailed analysis and policy of those attestations. But this is a very kind of early but vibrant field of development where, I mean, at least by supply chain security standards, you know, before SolarWinds, there were probably, you know, tens of people in the world working on this, and maybe we're up to 100 or more, maybe even hundreds of people working on this space now. So there's a lot of people interested in doing these kind of cool experiments, and none of it's come to a significant enough conclusion that we could state this is the way you should do it. But there's a lot of good ideas for how you can do these things, and it certainly aligns with what you say, like providing that verifiable and auditable metadata for different aspects of the supply chain. Definitely something that's being investigated. Great question, thanks. I don't know when you want me to stop. Does anyone else have a question? Sure. Where are we intended to publish the attestations? Right. Yes. Brilliant question again. Really do feel like you did your homework. So the question was, where do you publish the attestations when you've generated them? And typically the expectation is that they kind of sit adjacent to the binaries. They very much act like kind of a detached signature. in that if you tamper with an attestation, because it's authenticated, invalidates the authentication of the attestation itself. So you can just put them alongside the artifacts, but there has been some thought go on into how do you build a scalable system to store and transmit these things. And we don't have some very good ideas, but the systems that are adopting SLSA today, so NPM and Homebrew are the big ones that are kind of public where you can scrutinize the details. They're basically putting them in their registries and teaching their package managers how to look for those and do that verification at an appropriate point. If your SLSA build level 2 or higher, the metadata itself is signed. So if you were to tamper with, if you were to change the values in the metadata, then you wouldn't be able to verify the signature of the metadata. So yeah, but that is an easy. Having worked on systems where you do kind of signature verification, the more complexity you add to the verification, the easier it is to get the implementation wrong. And so one system I work on has this notion of thresholds of signatures. You want X people to sign a thing. And most of the implementations had a very naive, are there X signatures over the thing? Which means one person could sign it 5 times. And the verifier would say, God, great, this has been signed by 5 people. Brilliant. Let's approve this and ship it. But it was just one kind of rogue or over enthusiastic person. So we do it. We have to be very careful about how complicated we make verification. The more complicated it is, the harder it is to implement correctly, and the greater a chance of it going wrong. But we rely on the metadata itself being authenticated to avoid tampering with the metadata from being able to compromise the property of the system. So that's a good insightful question. Anyone else? Any remarks, heckles? Andy's desperate to kick off over there.
Well, I was going to ask about the concept of SLSA response, but it's covered by questions to it. What do you consider the weakest point of the SLSA specification on trusted infrastructure for, let's say, consumer of the trusted cloud?
What's okay? So shouldn't have agitated the beast, I guess. What do I consider to be the weakest point of the SLSA specification? I'm going to ignore the rest of the question. I think the weakest point of the SLSA specification is the setting and conveying expectations. Like I talked about it quite a bit in the talk because it's a very important piece of the of a SLSA ecosystem, but the specification doesn't have any concrete guidance around how to do that. So you told you should do it, and you kind of left to your own devices to figure it out. So that is a definite weakness, and that's something that I would like us to improve in future. And I think it's one of those things where until we have had multiple people try to build something, I'm a firm believer that you can only get so far with theory alone, and you have to do a certain amount of implementation to explore the consequences of the design decisions you're making. And so we need to do some of that implementation and consequence analysis before we can make concrete recommendations. So yeah, thanks, Andy. Great question.
And thank you to Josh, and thank you to Marcel, as previous speaker. Much appreciated. Your time this evening is, as I say, deeply appreciated. And again, if you have any further questions, please engage on Discord. We will not have a DevSecCon London next month as people gear up for the festive season, which in this country is basically stuffing turkeys both individually and into ourselves. And we look forward to seeing you again the next year, where we will perambulate across the great city of London with more frequency. Good evening, and thank you.